Okay, welcome back to Mrs. Monroe's favorite third period math class. We're here in Math 7 today. Okay, our lesson is it's actually 7.1 now. And the topic is classify angles. And make sure you guys put your name. Today's the 20-something. 23rd. Thanks. And this is period 3, as mentioned before, our favorite third period class. And the essential question is, how do we classify angles? So I said before, we're going into our geometry unit, but we're still using all of the algebra that we learned before to do the geometry. Okay, we have some new vocab. The first thing I want you guys to know, and this is probably one of the most important things in this lesson, is what vertical angles are. Vertical. Okay? These are two angles that are opposite. Two angles that are opposite. And here's another vocab, congruent. Congruent. Underline that word, congruent. Two angles that are opposite and congruent. And then underneath congruent, draw maybe a little arrow. And congruent means the same angle measure. The same angle measure. So a lot of people think that's like, does congruent mean equal? Not necessarily equal. That's my new theme music. Thank you. So two angles that are opposite, and we'll define opposite in a moment, and congruent. So same angle measure. So like, if you had one angle with 30 degrees and another one with 30 degrees, would they be congruent? Yes, they're the same exact angle measure. Okay, so that's vertical angles. We're going to draw a picture of these things. Okay, so I'm just going to draw like a big X here. And whenever we draw lines in geometry, we put little arrows at the end to signify that that will go on forever and ever. So kind of get used to that. You'll see a lot of lines with arrows. And I'm going to also label my angles. So there's 4 angles within this X. So we have 1, 2, 3, 4. In geometry, they will label everything so that you know when you're talking about someone or something, sorry, you can say, oh, angle 2 is. Okay, so you have some way to identify the angle. They won't just say, oh, that angle, because then everyone's like, well, what angle? So they have to name and identify the angle. So within this drawing here, we have vertical angles. The first 2 vertical angles are 1, opposite of 1, and the same as 1 is 3. Can you guys see that? It's opposite and it's the same angle. If I took a protractor and measured this, it would be exactly the same. So this is how we write angles. We do this little, like you guys just did these with inequalities, so it looks the same, right? Angle 1, and to show something is congruent, there's shorthand for that too. You do the equal sign with the little squiggly line over it. So angle 1 is congruent to angle 3. And that's how we show those vertical angles are the same. There's 2 more vertical angles in this. These 2 were there, and now 2 and 4 are also vertical angles. So comma, angle 2 is congruent to angle 4. So what does vertical mean, like in the real world, not just geometry, but can you guys show me with your hands, vertical? Good. So we've learned vertical is going up and down. Horizontal is flat, like the horizon, right? but vertical is straight up and down, okay? So even though the 1 and 3 are not straight up and down, we could rotate it and then they could be, right? If you rotate it. So just think it's directly across, opposite, and they have to be equal. Yes?
For the angle, like how you did the angle 1, could it be either way, like that?
Yeah, you could redraw it however you want, but just keep in mind 1 and 3 are congruent and 2 and 4 are congruent. Okay? So, there's a problem that goes with this. So let's call it example 1. And it'll say solve for x. And then there's going to be a drawing. There's lots of drawings in geometry. So I'm going to draw another one of these x's with the arrows. And then I'm just going to put some information in here. On the left side, I'm going to put 3x and then the degrees sign. And on the right side, so opposite of it, I'm going to put 9. So when you solve for x, we already said up here these two are equal, right? They're congruent. So to solve, you just remember there's a big equal sign in the middle. So you write 3x equals 9. They're equal to each other. So what will x be? 3. Good. So we solve by dividing. We've already learned all this algebra. So x is equal to 3. And you don't put degrees. It just says solve for x. You don't have to put degrees there. Just 3. And you can plug it back in and check. Is 3 times 3 9? Yes. So you know it worked. So that's how we solve for vertical. You'll get 2 numbers. One will have a variable on one side, and you just set them equal to each other. Okay, we have to look at another kind of angle, and these are called adjacent. So on the left-hand side, put adjacent. Adjacent angles. Oops, I can't even spell today. Look at me, guys. Adjacent. There we go. Adjacent angles. Adjacent means next to. Did you guys know that? So let's just put in quotes, next to. Adjacent means next to. And I'm going to draw another picture. Same kind of picture here. Kind of like an X with the 4 arrows. And I'm going to put the numbers again, 1, 2, 3, and 4. And if the book asks you which angles are adjacent, then you start listing them. So angle 1 and angle what? What's next to angle 1? 2. 2 is right next to it. Do you see it? Not vertical, not opposite, but right next to, like next door neighbors there. And angle 2 goes with what? Angle 3. Angle 3 can go with angle 4. And angle 4 can go with angle. There's no 5s and 6s here, guys. There's a 1.
I knew it.
Okay. So right next to, like next door neighbors, 1 and 2, 2 and 3, 3 and 4, and 4 and 1. Those are called adjacent. All right. There's a way that we name angles. So remember how I said sometimes they'll just call it angle 1 or angle 2? There's another way they do this, and it's a little bit more confusing. So on the left-hand side, write naming angles. And we'll just draw one of these. So just do like one Pac-Man mouth or whatever. Whatever you want to call it. Okay? And I'm going to call the vertex, I'm going to put a dot on the vertex. Remember that word vertex? I'm going to put a dot there and we'll call it Y. And I'm going to put a dot somewhere on the top line, and we'll call that X. And another dot on the bottom line, and I'm going to call that Z. I'm also going to put a 1 in here to show this is angle 1. So there are 4 ways to name this angle. So I want you to write 4 ways. The first way is the most obvious one. Angle 1. It's right there. Angle 1. That's what we're talking about. Another name you can use is angle Y. See how there's a Y right here at the vertex? You can classify your angle and name it by whatever's at the vertex. So we can call this angle Y. The third way is to look at the letters, and you're going to start at the X, go down to the Y, and then over to the Z. So we're going to call this angle X, Y, Z. The vertex always has to be in the middle when you're naming it. Okay, it's the middle one. So if we can go X, Y, Z, we can also go backwards and go Z, Y, X. Those are the 4 ways I can name my angle. Angle 1, angle Y, X, Y, Z, or backwards Z, Y, X. As long as Y is in the middle where the vertex is. That's how we name them. Okay, there's quite a lot of vocabulary in this lesson, so I'm going to break it down real quick because a lot of you know this. So let's go with acute. A lot of you know that one. That means less than 90 degrees. Anything smaller than 90 is acute. This says a little bit of review from elementary, so I'm not going to make you write a bunch of stuff on this. And then we have right. Right angles. Exactly how much? 90 degrees. Exactly. And we always do like a little box with that, like I made you guys do with your name. Some kind of box to signify it's 90. And then we have obtuse. Do you remember that word? Obtuse just means greater than 90. Greater than 90 degrees. So really, technically, it's between 90 and 180 is how you guys will see it. And then there's a 4th one, but a lot of people don't know this one. It's called a straight angle. Straight is, it kind of seems weird that you would call an angle straight, doesn't it? Like you would think an angle has some kind of non-straightness to it. But it's a exactly how many degrees?
0.
No, exactly
180.
180. Good. So you guys saw on the protractors, remember?
Yeah.
See how it was like the flat line was at 180? Oh, that's what a straight angle is. Okay, so we have these 4 things, and I know a lot of this is review, except for straight. You might not have known that one. Okay, I'm going to flip my paper over. Okay, there's a couple more things we're going to define. So on the left-hand side, put complementary. Some of you guys heard these terms before too.
It's free.
Complementary. This one means it's sum of angles. I'm going to do this little sign meaning angles. It's a little way to abbreviate the angle apostrophe S. Sum of angles equals 90 degrees. Complementary means the sum of the angles is equal to 90 degrees, and I'm going to draw a picture for you. Lots of pictures. This is a right angle. I can separate this right angle. Let's just start with 2 angles. So I'll draw a bisecting line here. These 2 angles now that I've created, they have to add up to 90, right? Because the original was 90. So this is complementary. So we can label these. Let's label this one angle 1 and this one angle 2. So I can say angle 1 plus angle 2 equals what? 90 degrees. That means the sum, right? When you add them together. That's complementary. The other kind is called supplementary. You guys saw this on the pretest today. Some of you figured that out. So supplementary means the sum of angles equals 180 degrees. So this is very nice. There's only two things you have to remember. Complementary is 90, supplementary is 180. That's it. And that will go with you for a long time in math, okay? So complementary is 90, supplementary is 180. We're going to draw a picture of a straight line. I'm just going to draw one line coming out of the top of it to make two angles. And I'll call these two angles 3 and 4. 3 and 4. So now I can say angle 3 plus angle 4 equals what? 180. So those straight lines are going to be supplementary. They add up to 180. Could I draw more angles in here? Could I put like angle 5, angle 6, angle 7? Yes. Yeah, and they still all add up to 180. They'll be all different measures, but they will add up to 180. So that's supplementary. Alright, so how you see these in algebra, we just have two more and then we're done. Two more examples. So example 2 we're on. Both of these we're going to find the missing x, okay? I'm just going to use x for a variable. So the first one, we're going to draw a 90 degree. Okay? And then we're going to bisect that again, just like my little picture above. But instead of calling it 1 and 2, we're going to call this one 2x degrees and this one 28 degrees. What do these two angles have to add up to?
180. 90.
Try again. 90. Okay, so we're going to take 2x plus 28, and that has to equal 90. Now this is just a two-step algebra problem. So what do we do first? Subtract 28. Draw your line under it. 2x is now equal to 62. Second step, we divide by 2. So x is equal to 31. That's it. So if you have a picture like this with a 90 degree, you know you can solve it by adding up to 90. Some people start to see shortcuts and they're like, oh, before I write all this, I'm just going to subtract 28 from 90 because I know that's the difference, right? Yeah. So a lot of you guys that are more advanced or getting more advanced, you're going to start doing it that way, and that's fine with me. Last example. Now we have to solve a supplementary. So draw your straight line, just like the picture above, but instead of 3 and 4, I'm going to put some numbers there. So I'm going to call this obtuse angle here 123 degrees. And the smaller acute angle, I'll just call it 3x degrees. So to solve for this one, what does it have to add up to?
180.
Good. So we have 2x. Oh, sorry, I was looking above. 3x. 3x plus 123 has to equal 180. So again, it's a two-step. So subtract the 123, and you have 3x is equal to 57. Then divide by 3, and we get x is equal to 19. Again, you could just skip the two-step and in your head do the 180 minus 123 if you're good at that and you know it's 57. From there, you could divide. So a lot of these problems you'll start to see shortcuts. So there's 3 types of problems we did, just to recap. We did the supplementary, the 180. We did the 90, which is complementary. And then when you flip it over, you'll see we also had to solve the vertical in example 1. This is solving for vertical. So 3 different ways. Vertical are equal to each other. Complementary add up to 90. And supplementary add up to 180. 3 different types of solving for x. But the algebra doesn't change at all. That's the good news. So since you guys did so well with chapter 6, all the algebra stuff, you really are only adding just a few more geometry rules, and then you guys will have it. Okay? So we're going to do some practice that's in the book. And it starts on page, what did I write up there? 539, I believe. Okay, 539, and we're going to do 1 through 11. And then what did I put after that?
15, 24, and A to D.
15 on 24, you only have to do A through D. I think it has like 5 sections.
And then it says 25 and 26.
25 and 26. Thank you. So this is the practice. So you're going to open up your book to these pages, and I'll kind of walk you guys through some of that.